Ladies and gentlemen, please welcome Executive Vice President of Cloud Infrastructure and Management, Raghu Raghuram.
Good morning. So this is going to be one of the easiest introductions I've ever done. Those of you that were present in the main station need no introduction to Dave Hitz. And even those of you that have not seen him before, he's a legend in the Valley and legend in our industry, co-founder of NetApp, the Waffle file system, and as you see, a great presenter to boot as well. So today, NetApp is going to be talking about, along with one of our joint customers, how they've done to storage what VMware has done with servers. For a long time, our two companies have partnered very closely and very successfully in the marketplace. And it gives me great pleasure to introduce Dave.
This has been an exciting year for us. NetApp turned 20 this year. What that means is, legally speaking, if we were a person, we still couldn't drink. But it's kind of an accomplishment. I mean, I think the half-life of Silicon Valley startups is 6 months, I don't know, 10 years. So getting to 20 feels good. We made it into the Fortune 500, which was exciting. And we made it into Forbes' list of 100 most innovative companies. So it's just been a cool year. And when you hit these kind of milestones, I think it makes sense sometimes to think back and just think about how the world's changed. And in the world of data, especially, it seems to me that there's been a lot of changes. I mean, when I think back to NetApp as a startup, we were primarily focused on the kind of data that realistically only its mother could love. I mean, schematics, source code, maybe somebody's budget. I mean, it's important to somebody, but it doesn't get anywhere close to your heart. And I think about what so much data is today in the social media world and in just what we're doing now with IT. I mean, data could be your baby's first steps walking. It could be love letters. It could be your medical records. I mean, stuff that's so personal and deep. And I think that's changed the rules for what data management means. The whole combining of the mobile and the personal with the corporate, like how do we keep this stuff straight? So just looking back 20 years and seeing that transition kind of gives me some perspective on how the world's changing. One of the things that one thinks about is, how did we get here? How did this happen? And I would say the answer largely is data ONTAP. Data ONTAP is our storage operating system. And when I just look at the capabilities, I mean, one of the things that sets us apart from the other storage vendors, we just keep putting more capability into data ONTAP. So to some extent, our R&D dollars aren't spread thin because it's data ONTAP, and it just keeps doing more and more. I thought it would be interesting just to look at the history of what data ONTAP's been focused on. When we started, we were absolutely a tech and internet company. I mean, at that point, ONTAP was architected for small engineering work groups, and just the initial stuff, really, it was programmers doing Sun workstations, and then eventually hardware design and chip design. The thing that was so lucky for us, and you can see I've overlain what we focused on with our revenue, we built a storage system that worked great in the internet environment, TCP/IP storage system. So when the dot-com boom came along, it was just like, zoom. And then you can see that drop there. That's where anybody remember that tech crash thing? So that hit us too. In fact, there was a 6-month period when if you looked at our 10 largest customers from the previous year, none of them purchased a storage system from us. So it was brutal. The only reason we didn't die, I mean, we could easily have, was we really focused on a transition to the enterprise. That's when we added SAN into our storage systems and started partnering with folks like Oracle and SAP, and just really a mindset shift. And it took a while for that new approach to turn things around. But it did. Mid-2000s, around 2005, we really started focusing on storage efficiency technologies, data deduplication and thin provisioning, and using cheaper drives, the SATA drives. And that turned out to be a really good timing with the crash of 2008. Anybody remember that one? that a lot of people were looking for ways to save money, and people who had said, I would never run production data on SATA, all of a sudden were going, well, it's either that or nothing. So that helped us come back up. And I would say more recently, the real focus has been on this whole idea of shared infrastructure. How do you do the storage behind virtualized and shared environments? And I mean, we've done so much with VMware. I can tell you, we've been working with VMware for a long time now. When the news came in that our biggest competitor, EMC, had purchased VMware, what's the phrase? We were shitting bricks. And one of the things EMC said was, they said, we want to run this thing as an independent company, and we want it to partner and work with the industry, and man, they did it. I have so much admiration for EMC that they really took that approach, and for Diane Green, who was running it at that time. I mean, it has been an awesome partnership through the years, and so I really appreciate that. So what happens going forward? I mean, I see that's the foundation where we've been. Two key themes. The whole cloud world, the public clouds, private clouds, and what should you keep on your premises, and what should you keep somewhere else? And, you know, I mean, I think that's going to be a long time playing out. Tom Georgens commented yesterday that, you know, the cloud is here today, even public external cloud, absolutely here today for certain apps. I mean, if you're doing website hosting, yeah, public cloud's here, it's safe. Pretty much everybody does that. If you're doing blogs, yeah, public cloud. You know, when you start getting closer to the heart of your financials, your ERP system, not so much. I think this is going to be a 10, 20-year migration. But what's clear is, however you're doing it, internal, external, that the whole model of the cloud infrastructure, the architectural model, and I think cloud really breaks the old way that data management has been done. I mean, if you think historically, data management was done on the server. I mean, it was either built into the operating system, or you ran Veritas on the server, your backup app, whatever it was on the server. And the server has disappeared as a place to do data management. Because if you think about it, with virtualization, you've got the virtual machines flitting around from physical server to physical server. You can't do the data management at the physical server like the virtual machine just left. So that's a bad place to do it. But doing it at the virtual machine layer is problematic too, partly because you proliferate, you have so many of them, and you get into issues if you run backups in virtual machines. For instance, you get this storm where all of them try and do their backup at once. And so as a result of that, we see a real trend towards the services that people used to expect in the physical server. People are starting to say, we would like that to move into the storage systems. And we believe that's really turning the storage systems into something more complicated, into a data infrastructure. And that word infrastructure, what does infrastructure mean? I think of infrastructure as anything that's centrally managed by a few people and used by lots of people. So you can think of the highway system or the electric system, the plumbing. I used that analogy in the other presentation. In the computing world, though, there's really only 3 layers of infrastructure. The 3 layers are compute, networking, and data on the physical side. You could argue that virtualization is emerging as a layer of infrastructure on the software side. And I put start dates on this. The start date 1964, that's not when computers first shipped. The first computers shipped in 1954, but they were very specialized computers. And what happened in 64, the reason for that date is IBM shipped the IBM 360. And that was a computer that was intended to be generic, good for scientific, good for business. You know what the 360 stands for? 360 degrees around. I'd never learned that, but it was the degrees in the compass. And that was the beginning of compute as an infrastructural layer. And I would argue that other infrastructures have only broken out twice in the history of computing. The first time was networking, and I put 85 there. I really think it was around the beginning of Cisco and PCs that network emerged as an infrastructure. Before this, it sounds weird, but networks were silos, which almost sounds like, how could a network be a silo? But if you think back, every computer vendor had its own network. DEC had DECnet, IBM had Token Ring. Everyone, they were almost more like computer interconnects than real networks. And it wasn't until we had PCs everywhere and people started looking at client-server computing, all of a sudden we needed an infrastructure to connect all of the PCs to everywhere, and they could talk to all of the servers. So networking emerged as a separate infrastructure. I believe that what's happening with data is similarly driven by the need to share. And the biggest driver of that, as I said earlier, VMware, suddenly we no longer have these static silos where data can just sit fixed behind application, server, data, just fixed in that silo. Suddenly VMs are moving around and maybe even migrating into a hybrid cloud somewhere. We've got to have a much more flexible infrastructural model for data. And I would argue it's 20 years behind what happened on the network. And so I believe that we can look at the network to learn what are the rules going to be? How is this going to play out? And if I think about NetApp's network, 20 years ago, we're 20 now, we installed a network, and ever since then, that network's been up and running. This router will go down, that switch will down, individual components fail, but the network infrastructure as a whole, our network's been up for 20 years. 20 years isn't quite immortal, but we use the term immortal sometimes to describe what we're doing. And it sounds crazy, except when you think about infrastructure, you do start to think of it that way. Nonstop, never down. Things are failing over. And the other thing is think about the scaling of a network like that. We started, there were 3 of us, we installed this little network. And now there's 12,000, almost 13,000 people at NetApp. So just in terms of the number of people, it's scaled by a factor of almost 10,000. If you look at Moore's Law scales by about a factor of 100 per decade. So that's another factor of 10,000, just the improvement. So you multiply those two together. NetApp's network, which has been up now for 20 years, has scaled by a factor of 10 million to 100 million. Well, it's just kind of mind-boggling. I know 100 million is not infinite, but for all practical purposes, and one of the amazing things is you plug these network nodes together and I keep talking about networks, I keep talking about Cisco. We're 20 years behind, but all of those things that you just take for granted that sound so crazy when you apply it to storage, that's what we're aspiring to. And in a lot of places, we've started to deliver on it. I don't know that we can do a scaling factor of 100 million, but maybe over another 20 years. The clock down here is says 49 upside down, 50, I don't know if anybody backstage can hear me, but a timer would be nice. So physical IT infrastructure. I used these words before. What we're calling this new data infrastructure, we call it the agile data infrastructure because it is such a fundamentally new thing that we're trying to build. And we're starting to deliver on. And the words that we use to describe it, intelligent, these nodes need to communicate, need to talk to each other, need to migrate data, need to have a lot of automatic capabilities here. Immortal, or as close as you can get, really non-disruptive, even as individual systems die. And over time, to me, immortality, a lot of it, it's not about the system staying up as long as you own it. It's about what happens when it's time to replace this system with a new system. How do you conveniently get the data to a new place and the whole thing's transparent? That's part of what I demoed in the previous thing, was just the data moving without VMware even knowing. And finally, the infinite scalability. And that doesn't mean infinite today, but over time, the ability of this just to keep scaling and growing. So what I'd like to do is in a minute, bring Luke Norris up. He's the CEO of PeakColo. PeakColo is a very interesting company. They're a cloud provider. And the problem that they solve with a lot of their customers, a lot of folks out in the computer world, people who've been selling computing equipment, think VARs and resellers, a lot of their customers are saying, hey, I wish I had a cloud. Well, every VAR can't stand up their own cloud. And yet, when you look at so much of the work that VARs and resellers do, it's about helping customers do installations and do the configurations and what's the right way to run SAP or Oracle or whatever the product is. And so, what if someone could do the back-end infrastructure and let all these different companies provide cloud services? That's what PeakColo does. Very interesting. And when I think about the challenge that they face, and I think it's a challenge that a lot of people face, you've got this balance between safety on the one hand, because everyone knows with IT, if what you're doing is not safe, you're just up a creek. You get fired if the stuff breaks. And yet, if you don't innovate, you end up stuck behind. And so how do you balance safety and innovation? I think that's one of the challenges that Luke's faced as he tried to choose vendors to work with. I can't choose the most dodgy thing, but I need something that's safe and reliable. He's running tier 1 kinds of environments. And so I think that balance is something everybody has to kind of wrestle with these days in IT. So here's a description that Luke gave of NetApp, and as part of the reason I brought him up. The flexibility of NetApp data on Tap 8 cluster mode is invaluable to us as a service provider, allowing us to be much more nimble than our competitors. I don't know any storage operating system technology that comes remotely close to it. So with that, let me bring Luke up. And
thank you. So when I was told I was going to do this speech, I was all excited, and now I just realized I'm following Dave Hitz, so little unnerving, to say the least. So I'm PeakColo, and thanks everybody for voting for NetApp. That was a great super session in that aspect. There we go. So we're 6. We turned 6 this year, not 20. And we do deliver, enterprise or carrier class service. This is built on Brocade, NetApp, and a flexible of Intel and AMD servers. We focus just on white labels. We don't deliver an end user service. This is true sort of infrastructure level that's built out in wide scales so that service providers or VARs can build on top of this and deliver real production apps. We don't look for disaster recovery. We don't look for test dev. But if they come, great. But this infrastructure is actually built to drive cloud economics. We're talking about 1 terabyte should perform like your 100 terabyte, and so on and so forth. So it's real high-value, industry-leading stuff. And it's mainly built on VMware, and that's also why we're here. So in these Tier 0 apps, it can be anything. And if you think about an infrastructure from a storage aspect, it has to run anything. So Hadoop, large, half petabyte, petabyte, multi-petabyte Hadoop systems running side by side with Oracle, running side by side with thousands and thousands of VMs. And how are you going to accomplish this? And at the same time, it's not the problem that we're dealing with. It's the same problem an enterprise would deal with. Now imagine you're trying to segment your HR department from your engineering department. So if you're going to build an infrastructure, you have to look at something that scales out wide and high. So what is infrastructure to a infrastructure provider? As Dave was saying, it's something that we wrestled with, and we're on our 4th or 5th iteration of this, and we think we finally found the sort of silver bullet, one may say. It's when people were actually building storage infrastructures in a provider class area, they would make it so that multiple little discrete systems, and they would isolate their customers based on these multiple little discrete systems. That becomes a management nightmare. Then you also might look at hard drive isolation or LUN isolation, but that still isn't enough to really classify as an infrastructure component. So the main challenge you're going to find in an organization as an enterprise or as a service provider that we find is the multi-tenancy factor and the need for not just security, but the need for isolation of workloads, the need to actually balance the noisy neighbor effect that comes with multi-tenancy. And this is imperative if you're going to bring these mission-critical workloads. It doesn't matter if it's a petabyte or if it's 40, 50, 60,000 IOPS. You need to have it on the same size. And the ability for it not to be down. And this extends well past just high availability, because even high availability systems need to be upgraded. They need to be maintained. They need to be forklifted. You need new systems coming in. To schedule a downtime with 1,000 service providers that each have 1,000 customers, that each have 1,000 VMs is a near impossibility. So the ability to literally do data migrations on the fly of physical and virtual. This isn't just virtual, it's heavily virtualized. But now you have the LUNs attached with Oracle to physical hosts. You have the LUNs attached to AS400s or Mount Vols. So the ability to literally migrate all this data seamlessly, non-customer impacting, was imperative to actually call your data center infrastructure and to call your data layer infrastructure. So obviously we picked ONTAP cluster mode. It's large in part why I'm here and why Dave did his earlier presentation. And if you think about it, as Dave said, there's this balancing act. This was a new technology. But if you look back through the Spinnaker acquisition and then the GX line that had been running in the high performance area, it wasn't so new, especially around the NFS side. But we don't just deliver NFS-based solutions with VMware, we also needed the SAN functionality. So to get that, C mode was essentially introduced, and that really gave us the comfort level. It had worked its way up through all the carrier enterprise class features, and now it's delivering both SAN and NFS-based systems, and really sort of mixed with our multi-protocol, multi-vendor environment. The upgrade was pretty easy. It is complicated to go from 7 mode to C mode on the physical side. Virtual, we're literally just able to vMotion everything over. But a very unique piece in doing this, once we decommed our 7 mode, we're actually able to move it and put it directly underneath the cluster mode just by reformatting it. And that's a kind of different mindset. Now you're actually not rack and stacking and literally throwing away on your forklift. You literally can repurpose gear. You can build different 0 tier levels. You can have a old tier even, not just a slow tier. I mean, there's all sorts of different economics you can derive from this. And as a provider, that's what we have to look at, the economics that are providing and driving our solutions. The 100% SLA scale. Scale's one thing, and clustered systems have been around for a long time. They've been able to scale out wide very easily. But now you're actually able to scale multiple base systems, single management console, SAN and NFS. I mean, we can literally go from a petabyte to, I think, 22 petabytes just within a virtual server, the virtual SAN that's in there. I mean, that's an immense amount of scale without having to change a single configuration. You're just literally racking the new equipment right into the system. And once again, delivering both iSCSI back into VMs, delivering NFS, delivering really any mixed system and workload you need. So the complicated part is to derive value on multiple levels. You do have to scale up because particular applications just need throughput concerns, but you also have to scale out. And we see a tremendous amount of value in scale out. Scale out for us as a provider allows us to discretely balance workloads between all the heads, between the management of those heads, but it's still derived from a single engineer, as you saw Eric, can manage multiple petabytes. You put several engineers around the clock, and now you can manage multiple sites and multiple petabytes. And this scale-out architecture derives good economics. You don't have to buy the largest system anymore and actually sell all the way into its value prop. You can buy medium-tier systems and just keep patching them on right there. You're also going to derive much more speed throughput because now you have those medium-tier systems fully utilizing their bus systems. And then in the point of a failure, even though the HA takes over, simple one-line command, you can actually move the data. It's a virtual volume, a virtual SAN, across all these different tier systems, across the different heads, non-disruptively, keeping all the operations working. You can literally shut down the old SANs, repurpose them, pull them out. It derives an amazing amount of agility that finally makes data feel like it's infrastructure, especially to us service providers. So tying it back in with vCloud, we're predominantly vCloud. I'm just going to give Eric one more shout out. I think he's deployed 300 to 500 VCD installations. And each one of these VCD installations has many orgs, and each one of those orgs has many VMs. So we've done a fair share of actually bug testing vCloud for VMware, and we're happy with the release from the 5.1 that they're announced at this meeting. But when you look at this environment, you see a typical one cloud, a vertical tier of data. That vertical tier of data works. But now, 2 clouds, 3 clouds, 4 clouds. If you had to match that with a SAN, if you had to match that with quote-unquote infrastructure, it doesn't actually meet our expectations, and it doesn't scale out as well as it scales up. So now with C mode as that underlining layer, you can mix different workloads. You can put high performance on the 62s, you can put low performance on the 32s, you can scale out multiple 32s. You can really adapt the workload, and it's a single management construct, a single unified fabric, even from the data side, where literally one command can shuffle entire volumes and workloads without any configuration from the host side. It dynamically changes the environment. And this is what actually gives cloud economics. If we buy a system with, let's say, 300-400 hard drives in it, and that's on the SAS tier, another 500 hard drives on the SATA tier, another 100 hard drives on the SSD tier, you can chop that up once it's virtualized and allow 1 terabyte to achieve 4,000, 5,000, 6,000 IOPS, 100 gigs of SSD achieving 30,000 to 40,000 IOPS without having to buy the whole shelves, without having to actually manage the entire data. So now when you're a customer and you just need a terabyte, you need 2 terabytes, you're able to derive that by by just buying the 2 terabytes, not buying the 30 or 40 terabytes to get the spindle count and the head leads and everything else that you need. And that's where cloud economics is really going to derive value from the data side up into everybody's environment. One thing I'm extremely excited about is the release of ONTAP V, or ONTAP Edge. And this is what I think we're going to see from a lot more physical providers. It's this idea that the physical construct can be virtualized even further. So now the actual ONTAP can run as an appliance in a cloud. So now you can have your ONTAP actually on your physical facility replicating to the cloud using all ONTAP technology. You could fail over just by moving that ONTAP that's in the cloud to a higher disk spindle, and now it's actually got the speed and the performance you'd want. We're doing some very exciting things with this, and NetApp is definitely leading the way with us on it. We absolutely love the possibilities this brings out. And all this is built around the concept that if you have infrastructure, it literally can be agile enough to be virtualized. And actually, the C mode underlining is literally virtualized by moving those sands around. From that, I'm going to bring Dave back on. He's got some questions, and I think we're going to have some mics out.
Yeah, we'll do audience questions as well. You know, the last feature that Luke showed, this is leading edge stuff, the ONTAP running in a virtual machine. It's something that we've been playing with for a while. In fact, we use it as a simulator within NetApp engineering just to test new code. But we started thinking about how it might be useful for customers. And I was just rabble-rousing with our CEO, Tom Georgens, that we really should put ONTAP into a virtual machine and do something with it. And I had some ideas, not ending up to be the first one we shipped, actually. But Tom's comment, he said, I don't like ONTAP in a VM because I know what it's good for. I like ONTAP in a VM because I can imagine so many things it might possibly be good for. Just creates a whole new flexible model to have some of them physical and some of them virtual. So it's a place that we're exploring. This is early days for this technology, but you can imagine why Luke's the kind of guy we'd want to explore it with. So first question, who did you consider from a storage perspective? I mean, how narrow or wide was your netcast? So you already knew NetApp. We were wired in, right?
Not quite. Last year, we actually made the migration to C mode. At that time, and just slightly before that, we were actually doing HDS, and we also had some Dell Equalogics, and we also had a little EMC in there. And once again, it was all these little discrete SANs where we were mixing and matching to sort of fit the need of the customer. But the data was going up and down. It wasn't going side to side. And in the virtual environments, the data is now moving side to side. So we literally had to figure out an infrastructure level component. NetApp actually came to the plate before C mode was even released and sort of sold us on the idea on it. We actually put an ONTAP 7 mode version, ONTAP 8, but a 7 mode SAN in, got comfortable with NetApp, and then we actually made the migration in September to C mode.
Any audience questions? I believe we have some mics up. Where are the mics?
Next to the cameras.
If you are interested in NetApp or interested in vCloud Director for that matter, this is VMworld, any questions that you have, Luke and his team, and some of his teams here as well, they've got as much experience as anybody with some of this newer stuff.
Yes, sir. I work in the federal space, and we recently moved to NetApp because of the flexibility, but also the ease of use of the ONTAP system compared to other storage management systems. We operate in a mixed environment. With the advent of this virtualized ONTAP...
Sorry, both men and women, or mixed environment?
Well, that too. No, that that too. No, a mixed environment in our data storage types.
Different vendors.
Different vendors. Is there any thought with virtualizing the ONTAP software of using that to manage different mixed storage environments? Because especially in the federal space where I literally have 18-year-olds with 6 months of training managing a 1,000-node network, having the ease of that interface to manage very complex data infrastructures would be huge for us.
One thing we actually are doing right on that sort of note, C mode and 7 mode don't directly interop. The code bases don't match up. You can't use a lot of the features on 7 mode with C mode. With this virtual appliance, we're actually running the virtual appliance from an NFS mount point on the actual C mode. So the C mode's backing in the data. So essentially, we're actually accomplishing exactly what you're talking about. That back end could be Hitachi. It can be any vendor that's actually running the VMware level appliance. You put all the storage into it, and then the ONTAP V actually is your interface for it.
We also have a product line we call V-Series, which is just the ONTAP head. And you can put it in front of other people's storage. And we've qualified a lot of other systems, including Hitachi and EMC. In general, what we find is people generally don't run that way long term. And the reason for that is if you have an EMC storage system or a Hitachi storage system, they're charging you for all the cool features they have in there. And if you say, well, I'd rather run NetApp's cool features instead of yours, the economics don't work that well. On the other hand, a few people have made them work. But on the other hand, when you start looking at a migration and saying, wow, I bought into this new NetApp model, but how do I transition all at once and capital depreciation and blah, blah, blah. Putting the V-Series in either virtually, as Luke mentioned, or with physical hardware, that can often be a useful part of a transition plan. So check out the V-Series.
Thank you.
Any other questions? And I've got, oh, here's one. I've got my own list of questions too, so if we run out, don't worry, we won't run out.
We are in the process of deploying 8.1.1 and trying to integrate VMware and also other applications. So one thing is we have a challenge is the features which is lacking is the snap vault and F policy and other things. It is still getting matured. So do you guys have those kind of requirements, and are you running in a mixed environment like a 7 mode and C mode to address these challenges?
In some of our sites, we do have a mixed 7 mode, C mode. I think it's down to literally one old 7 mode. We don't have a lot of the challenges that you have because we're delivering a little more vanilla-based service than maybe some of the enterprise functionality, and that's being derived upward into the software level for replication and other access. One delineating feature for us on C mode was the ability to actually have mixed code bases actually still within the cluster. So as you're moving to, say, a non-GA release or a very early release in GA, you can actually put that in a sandbox still within the cluster, only migrate certain workloads onto it to test it, and sort of migrate back. So that's just a huge feature for us in moving to the whole C mode paradigm.
Okay. And you actually did have a 7 mode deployed, and you were running in that environment. So you could have stayed, the 7 mode is just our name for the non-cluster mode. So you could have stayed in the non-cluster mode. Talk about what pulled you over to saying, I do want to be in cluster mode. I mean, it is newer technology. It's certainly where we're headed 100%. But we're in that period, if you remember back to when Microsoft introduced Windows NT, and there was the new technology, and you know, over time, everybody's going to get to the new one. But there's that period. But you decided to jump right onto the new one. Talk about that choice.
Just the stability and the fact that once you had a stable code set and a stable running environment in C mode, you're able to pull those 7 modes and all new feature sets. And as you derive more and more of these HA pairs, like I said, you can actually run them with different code sets. So we're able to keep adapting to all the new features that are coming and going to be coming out with C mode without actually inducing any extra variables in our environment. That new HA pair can run the new set for a month or two, find it stable, and then we can actually migrate workloads back to it, upgrade the older ones, and vice versa. So we just actually had a comfort level. And also, the load balancing feature with C mode was imperative for us. We find hotspots with one provider will just fire up 500 or 5,000 VDIs or a big Oracle solution on a particular HA pair because they are just buying storage from us. We don't always know what that particular IOPS set's going to be. So in C mode, literally one command and we can actually rebalance the whole system across all the HA pairs. I mean, that was a paradigm shift for us.
I see a question in the audience here.
Yeah, I have a couple questions for Luke. Could you talk a little more about PeakColo, the 100% SLA, and how you're able to do that? And then, and maybe related, is are you offering failover then between your sites for your customers, and how do you do that?
Our SLAs around the infrastructure in the actual environment. So the availability of the VMware under HA, the availability of this SAN to fail over from not only an HA pair, but then to fail over between HA pairs, and all the redundancy built into the environment of the network. A provider such as the VAR would actually balance you between data centers. And that's where you would actually start to achieve outside a data center or application level availability. We're doing something actually really, really interesting, and this will also be sold only through the channel with the Huru. They've done some source code development on Cloud Foundry. And we're actually looking at now tying that back in so you have application level SLA all the way through. Because if you're throwing your apps up into a pass level system, and we can harden that across the VMware and across the actual infrastructure, now we can actually start talking about application level SLAs. And I think, once again, that's a huge shift in the market.
Well, one of the things Luke didn't really mention when he was talking, but if you recall that stack, there was the physical infrastructure on the top, and then vCloud Director, and then above that was the virtual world. Largely, when you, one more back, please. Largely, when you look, we colored the green, and correct me if I'm wrong, but in general, the green part is the part that Luke's customers would manage. So Luke is doing the physical infrastructure, getting everything in place, getting the resources. The handoff, in a lot of cases, would be a virtual data center, a provider data center. And so then the customer, which is in turn a cloud provider, would take over at the provider virtual data center. Wow, there's enough acronyms here. But take over at the cloud virtual data center, and they would manage that top part. Because remember, a lot of these folks are people who are adding a lot of value of configuration, multi-site, failover, all of those kinds of things. In some cases, those are better done at the application layer. If you look at Oracle logging and stuff. And so that's where the division of layer comes from between Luke, back-end infrastructure, and his customers who still have a lot of value to add. Did I get that close?
You nailed it like we've done it before.
Any others from the audience? Yeah, there's one.
Question I have is around one of the historic knocks on NetApp storage, especially in a block environment, is the high overhead associated with snapshot reserve and 2x change rates and things like that. Can you talk about the overhead that you're seeing in your block environments and possibly the percentage of NAS to block that you're running today?
So I'll just look at that at two different ways. Predominantly, the amount of systems connecting to our C mode are NFS, NAS. If you look at the amount of VMs and actual servers that run to it. Now, if you flip that, the amount of storage we have is actually predominantly SAN. Because we actually have customers doing, say, Gluster file systems or level Hadoops, and they'll have physical nodes connecting back to the C mode at the SAN level.
So which cluster file systems?
GPFS.
GPFS.
Yep, it's pretty predominant in that. And around that, actually, I just want to throw out, one of the big things on C mode was the ability to move to PNFS, so we can actually move those SAN-based customers more and more to the NFS. Parallel NFS is going to be taken over here, and I'm still waiting for VMware to adapt it, and I think it'd be a game changer. But back to the overhead question, we actually don't see any dramatic levels of overhead on the actual SAN part. The biggest part of it is a limitation on how many of these HA pairs you can actually run SAN across, and I think it's just a logical construct of how much metadata has to be kept between all the systems to run it. But for the most part, we definitely lead and prefer NFS.
The evolution of SAN and NFS has just been fascinating to me. I mean, we started NFS and kind of had a religion about that, and then I showed you the picture when we got into the enterprise world, the business space. We really went over to saying, yeah, SAN and very neutral. When VMware first started, I just assumed that iSCSI would be the most natural model because VMware was starting with kind of lower end apps in the beginning, and Ethernet was cheaper, and iSCSI, and it just, I mean, they were spitting out VMDKs out the back. It seemed so natural. And when VMware ended up going down the NFS path, I was just stunned. I mean, I think it was VMworld maybe 5 or 6 years ago that our biggest customers kept coming up and going, well, we're actually using NFS. I would just assume I'd go, are you using Fibre Channel or iSCSI? And they'd say NFS. The most interesting answer I got as to why they were doing it, one guy just said to me, because I was like, well, this makes no sense. Why are you doing it? And the guy said, would you rather manage 10,000 LUNs or 10,000 files? Like, I manage 10,000 files on my PC, my photo collection, so it was, so a lot of people, and then once VMware built NFS right into the stack, and then Oracle did the same thing. Oracle's now got NFS built into their stack. That really hardened it a lot, isolated it from the separate operating system issues of, well, does this vendor's OS do NFS as well as that vendor's OS? So, I mean, at this point, but like you said, a lot of the Hadoop apps, and they want the block interface.
They need block.
So, at this point, we're pretty agnostic about that whole thing. A question from the audience?
Luke, you mentioned SLA around your infrastructure stack. Was wondering if the customers are asking for an SLA for single site infrastructure, or if you're using tools like SRM for secondary data center recovery and failover.
It's a little hard for me to answer because most of the end user are actually talking to our VARs and MSPs. And we really get the response from the VARs and MSPs on, we need this level of infrastructure between the sites. One thing that we went above and beyond through sort of the customers asking us is our data centers have actually been completely flattened. If you look at the paradigm that like Nicera's bringing to the market, et cetera, our switching fabric is it's literally a fabric. It runs on Trill, it's a Brocade VDX stuff. And it literally just flattens things from east to west. But our east to west is literally London all the way out to Seattle. And we keep these layer 2 extensions going that way, so you can, in most cases, can vMotion even intrastate or outside of the states because of latency has actually been dropping so much on these circuits. And now you can actually sort of do what you're saying. You can start providing SLAs around global shifting of applications, VDI deployments, follow the sun websites. The whole thing sort of happens there. So I do know our VARs are actually delivering that solution. We just don't get a lot of direct feedback from the end user.
Excellent, thanks.
I think there was
Another question here.
This one's for Dave. When do you foresee enterprise moving from 7 mode to C mode, specifically for the tools that enterprise uses a lot that NetApp provides, like Snap Manager for SQL, Snap Manager for SharePoint, stuff like that?
Right. So the question is, when do I see enterprises moving into the cluster mode environment? There's two different issues with moving into the cluster mode environment. Issue one is, when is cluster mode ready for prime time? And working with folks like Luke and looking at, it is ready for prime time now in pretty sophisticated environments. So that's question one. Question two is, how convenient is it to have some of your stuff in one and some of your stuff moving and to actually do the migrations? And so the initial focus has been to make it the best possible landing spot for new stuff. And then the focus behind that is to make it easier and easier to move over and remove the barriers. And so that'll be an ongoing process. Again, the best analogy I can think of is Microsoft going from Microsoft Windows to Windows NT. I mean, I remember for me personally, the first time I went to one of the NT versions and I immediately went into the start menu and flipped it back into classic mode, right? I mean, that's the kind of migration that's going on now. But we're certainly there today for some enterprises that, on the service provider, Luke, but some of our large corporate accounts that are heavy-duty enterprises are starting to dig in. But I do think it'll be a transition that takes a while. I had a question, Flash. You use a surprising amount of Flash, and not just the Flash in the NetApp storage systems. We have it as a caching layer within the systems, but also as SSDs. And I just wondered if you could talk about the sort of Flash dynamics that you've seen.
So a lot of features derived from the virtual environment allow you not to need, once again, a certain amount of storage, but actually just need a certain amount of IOPS. We have this very, very large VDI installation, and the beauty of it is I think for every 500 VMs, they use about 50 gigs. That's it, because they're able to link those clones.
So you've got data deduplication and cloning.
And cloning and all the other feature sets that derive that. But out of that 50 gigs, they have to derive 30 to 40,000 IOPS.
One of the ironies of these storage efficiency technologies, like thin provisioning, like deduplication, like cloning, is you can end up with, after you've crunched the data, a really intense load on a pretty small amount of data. I mean, it can be a problem.
So the beauty of that is if you put it on Flash and you have the right balance of switching and everything else for it, that 50 gigs running on Flash, SSD, or any number of systems can actually derive all those IOPS, deliver a level of service. And back to a pitch on cloud economics, that's cloud economics. That's the ability to have that level of IOP throughput and capability derived in such a small, little, tiny niche. And we don't run any hard drives in the systems anymore. They either boot entirely off SAN or have SSD in them. And we are looking at even locally caching some of the hotspot IOPS and eventually doing write-throughs even to the SAN. So you still have all the high availability, but you have that local cache capability for,
How many people were in the large session and saw the migration demonstration? Fair number of people. So one of the demonstrations that I did there was showing Eric, stand up, Eric. Eric was on that big screen. Thank you. One of the demonstrations was Eric migrating data that was on an overloaded system, and it was regular disks, onto a system with flash drives, and it showed the response time going from 5 to 0. And one of the things you told me when you and I were out visiting in Colorado was just one of your use cases for that technology that I thought was really fun, just kind of letting customers know.
Because we are so far removed from a lot of our customers, and troubleshooting can actually be hard in that aspect. One of these customers was having a database problem, running very, very slowly and erratically. They couldn't nail it down. So literally the beauty is ticket got escalated up to us, and we looked at the solution, and we didn't see any problems. So it was real simple. Eric ran that one-line command, moved them from SATA to SSD, had them rerun the operations. It didn't run any faster. Well, guess what? It's not the SAN. It's the operations. And that ability to have that agility for one line of code, move physical systems, multiple physical systems tied to a database onto a higher tier storage to have that level of testing, I mean, it was unprecedented to our end user customer.
When he mentioned that, I mean, that had not been our mental model of doing the transparent migration, that people would just kind of do it to see. I talked about the immortal. I mean, the ability to take an older system and evacuate the stuff so that you could retire that system without disrupting anything. That was kind of more of our mental model. But when Luke said, oh yeah, we were just curious, so to debug performance, we didn't think, but we put it on flash, and once it was on flash and it was still slow, then the customer was satisfied. Like, well, okay, I guess it's not that. The other thing you mentioned was you sell different levels of service to people, and sometimes people will buy the flash capability for the speed, sometimes they won't. And you said you'll sometimes cut them over just to, like, here's what your life would be like if you spent the extra money.
Yeah,
so again, it was just a fairly, maybe get them through a hard time once for free, and then going, but next time, this one's on us, next one's on. Just the flexibility of this stuff, the way you're using it was very interesting. It kind of opened my mind up a little bit about when it becomes a data infrastructure, you do think differently about it.
Opens up a lot more options.
Any more questions? One of the decisions you made, we have this construct, it's the virtual storage server, or vServer we call it. You made the decision to do one vServer per customer, cloud provider, or at least one vServer. What drove the decision to have a different virtual storage system per customer?
It's getting back to actually delivering infrastructure to our end customers. Instead of having these discrete systems, and by discrete systems, I mean separate little SANs to deliver the security and the isolation that the customer want, we're actually able to put the data into a vServer, tie the vServer to the unique VLAN and IP addressing scheme on a customer-by-customer basis. And even if their customer had a HIPAA or PCI level requirements, give them another vServer. So that flexibility for literally, as you guys saw in the demo, one command line turns on that vServer, assign it to the unique IP, put it on that unique VLAN just for that end-user customer. Now you're actually delivering infrastructure. You have that one large system that can be delineated into small points and have all the value of a big system.
So you talked a little bit about this during your prezo. There's two more questions. Let's get to the two audience questions. Let's start here and then there.
Sure. I have a question for Luke. Our company has a pretty significant investment in Lab Manager. We're moving to vCloud Director for regression and build sort of efforts. We do about 2,000 deploys a week. We have an operations team that is mostly used to managing capacity, and we see the controllers fall over pretty significantly because of writes. I was curious about your approach to performance management and handling these things proactively rather than waiting until they fall over.
So you actually hit sort of the nail on the head on why we also looked at a scale-out architecture with the mid-level FAS systems. It's because if you're going to get these flare-ups, it's usually on the write. You're going to overload the write caching, or just the throughput on the write capability. But now imagine literally once the VMs start to show write latency and you're getting your alarms out of VCOps or VCD, the ability to literally have a system administrator see the high balance workload, literally in one command, move it to a head that doesn't have a high writing workload and rebalance out the whole system. For an enterprise or a service provider, I mean, that was a feature we just never imagined or could see. And it's available today in one command line, literally.
Thank you.
I think this will be the last question.
I have a question for Luke. In your upgrade from 7 mode to C mode, did you have any outages?
The upgrade from 7 mode to C mode is a forklift. There isn't currently really a way around that. What we were able to do from the virtual side was just use storage vMotion, and then from the physical side, we distributed multiple LUNs and the Gluster file systems and the other applications were able to migrate the data over. So it was pretty seamless. And then, as I stated earlier, the beauty was we literally took the old 7 mode and just threw it right up, and it became a C mode.
Yeah, so the one thing, I mean, it's a forklift. You don't literally need to get rid of the systems because the systems that we ship today can run either way. So it's not that kind of a forklift. But in terms of the data migration, it feels like that style. So you need to use the normal tools, as if you bought a new system, the normal tools to move things over. So let me close with a couple of thoughts. I said that what we're building now at NetApp, it's an agile data infrastructure. We're trying to do something so much bigger than just storage systems. And I use these words that in the networking world, I think when you say intelligent, immortal, infinite, when you think about like the internet, is it those things? Well, yeah, it is. Can we get storage there? I don't know. How are we doing?
Pretty damn close.
We're working on it. So I opened this session with some things about NetApp that we had accomplished in the last 20 years, the Fortune 500 and the most innovative companies. But I actually saved what for me is perhaps the most interesting one for last, which is the market share of data ONTAP as an architecture. Data ONTAP as a storage operating system now has the #1 market share in the industry, which I think would surprise a lot of people because EMC is still quite a bit larger than us. I mean, even on the storage side, of course, EMC is VMware and Documentum and all of these things. But how is it that NetApp can be #1 market share by storage operating system? And the answer is that EMC is numbers 2, 3, and 4. Symmetrix is their first one, and the Clarion, the Flare, is the second one. And in fact, if you look number 5, that is the NetApp storage architecture, the E-series that we got with the Ingenio acquisition. So it's pretty interesting to me when I look at this architectural picture of the storage industry. It is now largely dominated, at least when you look at this architecture view, by 2 companies. NetApp, EMC, NetApp are the top 5 storage architectures out there. So it's a pretty exciting time for us because when we started, we just felt like the little guys, you know, and now we sort of feel like we're in there neck and neck in terms of R&D investment. But the cool thing is all our R&D investment goes into that one OS on the heavy-duty feature side. The E-series is much more high performance, stripped down, but not as much on the feature side. So I think that's when you look and go, well, how could they be delivering this kind of innovation? I think this picture just kind of sets a sense of that. So let me just close first by thanking Luke.
Thank you
so much for joining me here and for helping me, Eric, with the demo in the other room. And feel free to visit us in booth 1402. You'll be there.
We're in the service provider booth, just in the corner from it.
And just right across here, and then there's the service provider booth in the back. So thank you so much. Really appreciate you coming.
Thanks, everyone.